So after multiplying in these matrices in MATLAB or in your calculator, okay, I get this matrix here, okay. So this is the so this is the matrix B, which is basically defined with respect to frame one, which is basically similar to rotation by 30 degrees around the z-axis in frame 0, okay. Now we would like to find the axis angle representation of this matrix, and for that I have brought this snapshot of our previous slides, okay, or, or slides basically, okay, and we'd like to use this formula to find theta and k, okay. So this is part B, okay. Part B is going to be, first of all, we would like to find theta. Theta is nothing but cosine inverse, and this is going to be the trace of B, okay, which is basically this matrix here. This is B. The trace of B is nothing but the sum of the diagonal elements, okay. Subtract 1 from that, and then divide everything by 2. And to do this, you need to basically find the trace first. So the trace is going to be 3 plus 4 plus 1, 8 root 3, 8 root 3 plus 2 plus 6, which is 8. And then don't forget about the 8 outside here, okay, which is part of the trace. So we have to multiply this by 1 over 8. And then we subtract 1 from here, and then divide the whole thing by 2, okay. And finally, this becomes what? Okay, so square root of 3 plus 1 minus 1. So that's cosine inverse of square root of 3 divided by 2, okay, which is basically what is the angle that has a cosine of root 3 over 2. You can see that from here. An angle is nothing but 30, okay, because cosine of 30 is root 3 over 2. So theta is 30 degrees, okay, 30 degrees. All right, and k, which is expected basically because we are finding the similar transform to RZ of 30, so we must get the same angle, right? K is going to be this one here. Yeah, this formula. I'm going to apply this formula. So K is going to be 1 over 2 sine theta. Sine theta is 1/2. So we have 1. So basically 2 times 1/2. 2 times 1/2 is 1. So we have 1 over 1. So this is 1. So this whole thing becomes a 1 here. So we only have the vector here. Okay, R32 minus R23. R32 minus R23, which is this one. So this minus this, which is minus 4. All right. Minus 4. Do not forget about the 1 over 8. Okay, it's taken as a common factor. Minus 4. Okay, and then for the second dimension, it's 1 3 minus 3 1 1 3 1 3 minus 3 1. This one minus this one. Okay, so I have this minus this is going to be yeah, a 0 basically. Okay, so it's a 0. What about the last one? It's 2 1 minus 1 2. 2 1 2 1 minus 1 2. Okay, this one is 2 root 3 minus, so it's plus 2 root 3. So the answer is going to be 4 root 3. Okay, so that's basically going to be minus 1/2. Okay, if you multiply the 0.80 and then root 3 over 2. So this is basically the vector, okay, in which we are basically rotating about, that is similar to A, okay? So this is similar to the z-axis. It's supposed to be aligned with the z-axis of frame 0. Okay, let's see that. Let's see in part C how we can imagine that. Okay, let me stop and continue in the next video.